We are now going to look at the next type of transformation for trig functions. So I first put down the reference points for both sine and cosine, and then I'm going to just remind us of that general equation. So we have y equals a sine, but what we're going to add now is a b. So the b is a horizontal stretch or compression, but what it affects is the period. So remember, period is the length for the trig function to complete one cycle. And so the period for sine and cosine is 2 pi. But by having a b value, what we do is we change the period. So I'm just going to put, to find the period, you actually just take 2 pi and you divide by b, and that will give you the period. So what we're going to look at is a couple examples. So our first one is going to be y equals sine 2x. All right, so we can see that we don't really have any other transformations besides that b value. So the first thing I want to do is find the period. So again, to find the period, it's just 2 pi over b. And in this case, it'll be 2 pi over 2. So the period is pi. So what that means is it will complete the cycle in pi units as opposed to 2 pi. So it's going twice as fast. So we're going to go ahead and set up our table. We're using the reference points from the original sine parent function. So in this case, the y values do not change. So we're going to go ahead and write all the y values that stay the same. But the x values, so this is what's very different about a horizontal stretch or compression versus vertical. So if this were a 2 in front, we would multiply the y values by 2. But for a horizontal stretch or compression, you actually multiply by the reciprocal. So since the value is 2, we're going to actually multiply the x values by 1/2. So I'm going to put that here. So multiply x values by 1/2. All right, so if the original sine x value was 0, we would still get 0. For pi over 2, we would now get pi over 4. Pi, we would get pi over 2. 3 pi over 2, we get 3 pi over 4. And 2 pi, we get pi. So we can see as we go from 0 to pi, this cycle length is just pi because it completes one full cycle in pi. So we're going to go ahead and draw a graph. And I'm going to go by just 1, -1. This is pi over 2, pi, 3 pi over 2, and 2 pi. And then we know in between would be pi over 4, 3 pi over 4. This would be 5 pi over 4, and 7 pi over 4, although we don't really need those. Okay, so now we will go ahead and graph what we have. So the midline for this is 0 because there's no k value, so I'm just kind of drawing a horizontal line. The amplitude is 1 because we have no a value or vertical stretch factor. So we're going to go ahead and plot the points we have, which are 0, 0, pi over 4, 1, pi over 2, 0, 3 pi over 4, -1. I actually should have drawn that at -1. All right, 3 pi over 4, -1, and then pi 0. So it looks something like this. So it's going to have, obviously the domain is still all real numbers, but what's different is it completes the cycle twice as fast, so the period changes. So let's go ahead and try one with cosine. So this time we're going to look at y equals cosine 1/2 x. So once again, we can see that we don't have any amplitude value or vertical stretch factor. We have no horizontal translation or vertical translation. So before we start, we're going to go ahead and find the period. So the period is 2 pi over b. In this case, b is 1/2. So 2 pi divided by 1/2 is like saying 2 pi times 2. So the period is actually 4 pi, which means it completes the cycle in half the time. In other words, it's twice as slow. So this time, because it's 1/2, we multiply the x values by 2, because remember, you always multiply by the reciprocal when we have a b value or horizontal stretch or compression. So we will set up our xy table. Remember, the y values are staying the same. So for cosine, it's 1, 0, -1, 0, 1. And then for the x values, we multiply them by 2. So 0 becomes 0, pi over 2 becomes pi, pi becomes 2 pi, 3 pi over 2 becomes 3 pi, and 2 pi becomes 4 pi. So once again, we can see that the cycle goes from 0 to 4 pi. So it takes 4 pi to complete the cycle. And then we will go ahead and draw this. We're going to need a lot more room here. So we have pi over 2, pi, 3 pi over 2, 2 pi, then this would be 3 pi. I need a little bit more room, 4 pi. And obviously you can adjust that. So this would be 5 pi over 2, and then this would be 7 pi over 2. Okay, so when we are drawing this out, we know that the midline is 0. And our amplitude is 1, so it's just one above and one below because we don't have any of those transformations happening. And we have 0, 1, pi 0, 2 pi -1, 3 pi 0, and 4 pi 1. So it's very stretched out. It's actually kind of hard to draw when it's this stretched out. And obviously you can scale your x-axis differently. I'm just trying to do it the same as how we've done it so you can see a major difference. All right, so we're going to do one last problem for a challenge. So we're going to actually combine all the transformations into one. So we'll call this a challenge problem. So we'll do y equals -3 sine x minus pi plus 1. All right, so what we have going on here, we have I'm going to try and go in order here. We have a reflection across the x-axis, which will affect the y values. Then we have a vertical stretch of 3, or an amplitude of 3. And I also wanted to put a 2 there, of course. So that will change the period because that is going to make it twice as fast. And then we have a horizontal translation of right pi and a vertical translation of up 1. Okay, so we're going to be doing a lot of things to these x and y values. So let's go ahead and do the y values first because it's a bit easier. So for the y values, we have to, let's see here, I'll pick a different color. So for the y values, we want to multiply by -3, and then we want to add 1. All right, so for the original y value of 1, we multiply by -3, and we get -3, and then we add 1. And so 1 times -3 is -3, plus 1 would be -2. All right, so we know that this, oh wait, I'm actually doing the wrong one. We're talking about sine. So 0 times -3 is 0, plus 1 is 1. So this will be 1, the middle one will be 1, and the last one will be 1. All right, for pi over 2, 1. So we're looking at 1. 1 times -3 is -3, plus 1 is -2. And then for 3 pi over 2, -1, we're looking at -1. -1 times -3 is 3, plus 1 is 4. Okay, y values done. So for the x values, we have to first multiply them by 1/2 and then move them to the right pi. So remember, the period is going to be 2 pi over b. b is 2, so the period is pi. And because it's 2, we multiply by the reciprocal, which is 1/2. All right, so we have 0. So we multiply, and remember PEMDAS. A lot of us get confused on what to do first. You do the multiplying first, then the adding and subtracting. So we multiply 0 by 1/2, we get 0, and then we add pi, and we get pi. All right, we multiply pi over 2 by 1/2, we get pi over 4, plus pi would be 5 pi over 4. Next is 3 pi over 2, next is pi. We multiply pi by 1/2, and we get pi over 2, plus pi would be 3 pi over 2. And then next we have 3 pi over 2, multiply by 1/2 would be 3 pi over 4, plus pi would be 7 pi over 4. And lastly, we have 2 pi multiplied by 1/2 would be pi, plus pi would be 2 pi. So you always want to check your period. Remember, the period is the length it completes, or the length it takes to complete one cycle. So from pi to 2 pi, that's 1 pi, and that's exactly what the cycle is. All right, so this graph is going to be, we have to kind of think about how we want to set it up because there are a lot more things happening. Okay. All right, so we have pi over 2, pi, 3 pi over 2, and 2 pi, and we'll go ahead and put the in-between values. So pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So thinking back to the last tutorial video, when we had multiple things happening at once. So the first thing I like to put in is the midline, which is at 1, because y equals k is the midline. Remember, this value right here is your k value. All right, the next thing that we want to do is the amplitude. So the amplitude is just 3. So we do 3 above, and then we do 3 below. Okay, so from here, we're going to go ahead and plot the points. So we have pi 1, 5 pi over 4, negative 2, 3 pi over 2, 1, 7 pi over 4, 7 pi over 4 is 4. I did not mean to put that there. Okay, 7 pi over 4 is 4, and then 2 pi is 1. So it's going to look something like that. So we can see that it completes the cycle twice as fast, and it has an amplitude of 3. It's flipped over, we moved it to the right pi, and we moved it up 1. So that is your second video on transformations of trig functions.